Hello everybody. In this video, let us discuss about reserved words in Python. So, what are reserved words in Python? So, reserved words are a specially designed words to do a specific task in Python. Just like in a bus, how do you have a reserved seats, right? In a bus, would you have reserved seats for ladies, reserved seats for handicapped, or reserved seats for escorts? Like that, we have reserved seats where only those designated persons have to sit in those particular seats. No other person has to sit in that particular seat, right? Similarly, in Python as well, we do have such reserved words where only to some specific actions or some specific task we have to use those words. This is not only in Python. In every programming language we'll be having the reserved words. So similarly in Python also we do have these reserved words, and in Python we do have especially 33 reserved words. We do have 33 reserved words in Python. So these reserved words, we cannot use these words as an identifier, or else we cannot use these words as a class, or we cannot use these words for defining functions and all as function names and all. Okay, only to certain specific tasks, whatever we are going to discuss right now, only for that purposes they have to be used. So now if you see the first set of reserved words in Python, we do have true, false, and none. Okay, so these reserved words, whatever you are seeing on the screen right now, so these are the reserved words related to the Boolean operators. So whatever the reserved words we use, these reserved words we can always use for the Boolean operators. So for example, so if I go to this particular Jupyter lab, okay, so and if I select this Jupyter notebook, I can always execute my code over here. So in the Jupyter lab, you can always install and you can always execute the particular Python code, or else you can always use VS Code as well. Okay, so to that matter, you can always use any other text editor as well. Okay, so this is the particular thing you can always do. So here, as we have to discuss about the true Boolean operator, right? So here, for example, if I say print of 5 equals to 10, so equals to, we have to write a comparison operator, where again print is a inbuilt function to print the particular things. Okay, so we'll be discussing later all these things, but as an example I'm showing you right now. So if I say print of 5 equals to 10, okay, so where we have to write double equals to, which is a comparison operator. So is 5 equals to 10? It is not equals to 10, right? 5 is not equal to 10. So now if I run this one, so the result will be false. Okay, so like that we can always have the particular Boolean operator. Okay, so we have got this Boolean operator. Whenever we are comparing this one, we have got false as the Boolean operator. Otherwise, if I say print 10 equals to 10 itself, if I say is 10 equals to 10, yes, 10 is always equals to 10 itself. So again, if I run this one, see, it gives the Boolean operator true. Okay, that is the case we can always have. And again, the other one is none, right? The other one is none. So none is a reserved word in Python, just like your null. Okay, in other programming languages, especially in Java, you do have null, right? So whenever we do not have any value, we will be keeping as null. So this is similar. This none word, reserved word, is similar to null. So for example, if I say, I can always assign a particular identifier as none over here in Python. So I can always say none, just like how you say variable equals to null. Okay, so in other programming languages you can always specify age equals to none. Okay, so now if I put if age is none, if age is none, right, we have to give colon as a syntax. Then I have to say print, this is some invalid age, right? So age I have defined as none. Okay, so that means age contains nothing. So if age is none, so age, the variable age contains what? None right now. So I'm comparing again. If age is none, print invalid age. So if I run this particular code, see, we'll be getting invalid age. Okay, so like that we can always use none as the particular reserved word. Okay, so this is the first set of, these are the first set of reserved words where they can always use it for boolean operators and all. Okay, so now the other set of words, if you see, we do have and, or, not, is. Okay, so we do have and, or, not, and is. These reserved words, they are used for logical comparison. Okay, we can always use it for logical statements. So sorry, it should be smalls. So except true, false, and none. Okay, all the other reserved words, that means all the other 30 reserved words, if you exclude these three things, again we'll be having only 30 reserved words, right? So all the 30 reserved words should be in small. Okay, only this particular true, false, and none reserved words, they should be having the first letter as capital. Okay, that is the thing. So now again, if you see and, or, not, and is, these are related to what? These are related to logical statements, right? Logical statements. And these are related to Boolean operators. So now if you see how we can represent and, okay, so if I go over here, for example, if I say some a equals to 10, okay, some variable b equals to 20, and c equals to 30, and again if I say result equals to b greater than a, okay, we can always pass what is b greater than a actually. A is 10, b is 20. Is b greater than a or not? B is definitely greater than a because b value is 20 and a value is 10. So this type of, this is a, the result is boolean. B greater than a is what? True over here. So we are passing this boolean value to this result. Okay, we are passing this boolean value to this result. Let me say result 1. Okay, and similarly I will be taking another variable result 2, where I will be saying c greater than b. Okay, so again this is what? C is greater than b or not? Yes, c is definitely greater than b, and again the value is true. The true value I am passing to result. Okay, so now if I say final result, okay, final result as the variable, final result equals to result 1 and result 2, I'll be saying. Okay, so whenever you are using this Jupyter lab, right, so whenever you are using reserved words, it will be showcasing in green letters. Okay, so that is the advantage. And not only that, you can execute n number of programs. Okay, each time you are executing, you will be having an editor. Okay, so again if I run this one, again it will be providing another editor for me. So like that, n number of programs in one place, I can always edit over here. Okay, so you have to install Anaconda for Python. So once if you install Anaconda for Python, automatically you will be getting this Jupyter lab. Okay, that is the case. So now if I say, if I say final result equals result 1 and result 2. So what is this? Final result equals to result 1. What is result 1 value? True. And result 2 value is true. Right? True and true, which is true again. Final result is true. So in order to explain you better, let me show you the truth table for and operator, for and reserved word. Okay, truth table for and. Let me show you the truth table for and. So now if you go to insert table, yeah. So for truth table for and, if you give, okay, we would have, if you say a as one variable and b as another variable. Okay, so the third one, a and b, if I say. So for example, if a is true, okay, if a is true and b is also true, then the result will be true. If a is true and b is false, then the result will be false. And again, if a is false and b is true, again the result will be false. A and b is false. I have to add another one. So, and again, if I say a is false and b is also false, then the result is false again. So this is the truth table for and keyword. Okay, so for and reserved word, we can always, this is the truth table. So right now what would we have? If you go to the Jupyter lab again, what would we have? We do have result. I am putting result 1 and result 2 in this final result. That means and, right? So true and true we do have. So if we have a value as true and b value as true, then the result will be also true. Correct? So that's why if I say print of final result, if I say, I will be having true as the result. Why? Because result 1 is true already and I am using and as the keyword, and result 2 is true. True and true are always true according to the truth table for and. Okay, that's why we have got true. Okay, so that is the case. And again, if I say 40, if I put b value as 40, and if I search again, see, now I am getting false. Why? Now is c greater than b? First of all, is b greater than a? Yes, b is greater than a. That is true. Result 1 is true. And is c greater than b? No, c is not greater than b because c value is 30 and b value is 40. So c is not greater than b and result 2 is false. So final result, what we are doing? True and false. We are saying true and false. Okay, final result is true and false. True and false according to the truth table of and is what? True and false is false again. So that's why we have got the result as false. Right? So that is the case. And similarly for R, right? For R, if I put R over here for the same thing, what I'll be getting? If I put R over here, okay? So in order to see the truth table for R, if you see over here, if I copy this one, so if A is true and B is true, A or B will be true again. If A is true and B is false, A or true will be true only. A or B will be true only. And if A is false and B is true, A or B will be again true. Even if one value is true out of the two things, if either A or B is true, A or B will be true always. Okay, and if A is false and B is false, then only it will be false. So this will be the truth table for R. So according to this truth table, so what we do have over here, I have put R right now, where result 1 is true and result 2 is false. True or false is always true. Okay, true or false is always true. And if I run this one again, see, now we have got as true. Okay, so in this way we can always have the particular logical operators and or. Okay, and again if I say for not, what is the other operator, what is the what is the other keyword? Not is the other keyword, and or not is the other keyword. So not, so negation, not is nothing but negation. So if you see the truth table for not again, so you will be having truth table for not again. If you see truth table for not, so we do have only two values. Okay, let me insert table. So if you have A, if you consider A as the particular thing, not A. Okay, not A. If you see true, it will be becoming false. If it is false, it becomes true. That's it. Negation is always opposite to the particular thing. If A is true, not A will be false, and if A is false, not A will be true. So according to that logic, so now in my final result, if I simply put not over here, if I put not, okay, so and now if I search again, what it should become? It should become false, because earlier it is true, now it becomes false. That is the thing over here, right? So like that, we do have the keywords, logical keywords. We do have another reserved word, is. So yeah, so is the other reserved word. So how we can represent this in this particular Jupyter lab? So let me say A equals to some 10 and B equals to some 10 as well. So now if I give print statement, okay, print command, if I give, okay, if I give print function, inbuilt function, and if I say A is B, is A is B? Yes, A is B itself, because A value is 10 and B value is 10, right? So what we should get over here? True. So this also will be printing true. So as we have discussed, okay, so whatever the logical statements which are used for logical statements, these reserved words, all these things will be having the boolean logical keywords, okay, either true or false. Okay, so again if I say 20 over here for B value, and again if I run, so it will become false, because A is not B right now, because A is not B. Okay, so that's why as I'm specifying A is B, it is saying it is false because A is not B. So like that we can always use the particular reserved words. So there are other reserved words as well, so we'll be discussing these reserved words in another video. Until then, have a great time. Bye bye.